All right, I think we're live. Okay, so after my previous failed attempt at getting the GLFW library running, I actually came across this video series where it actually explains it in very simple terms. So I am just gonna try to do that again from scratch. I actually tried it once and it did work. So let's just remove that, and I'm going to create a new project. I'm just going to delete the old project. Okay, so just open up the folder and create a folder called libraries, and here we're going to place the include directory and the lib directory. So whatever we downloaded, first of all let's put GLFW in here. Actually last time I forgot to copy this folder in, so I'm just gonna do that first. Copy GLFW in, and then it's lib folder, which is this one right here, because we're using Visual Studio 2020. We just need the glfw3.lib file, and that's it. That's the GLFW setup. And that for glad we're gonna do something similar. It just has the include, does not have a lib files, so I'm just gonna put all of this into the lib directory, and also has this header file. I'm just gonna put it in the solution directory directly, and now we just need to tell OpenGL where to find all this stuff. Sorry, we need to tell Visual Studio where to find all this stuff. Go into project properties. First of all, we need to add the two directories that we created. One is the include directory, so just add it like that and navigate to the include folder and select it. And then similarly we need to add the lib directory under here. I did do this before, but I'm just going to do all of this again. Alright, and now we can add the .lib file under link input, and then add this here. It's glfw3.lib and OpenGL 32.lib, I believe.
This tutorial, follow this step once your build is finished.
Okay, yeah, GLFW3, GLFW3 and OpenGL 32.lib. So we have those. We are finally, you actually need to add that header file as a source file. So drag this into source files. How would I know that? I mean, this website does not tell you to do that, as far as I can tell. Anyway, so if I create a C++ file now, can include glad with glad slash glad.h. Okay, inc include and glfw with glfw slash glfw3. Okay, is that it? Yep. So hopefully this won't give any errors. All right, so we got this running. That's nice. I think we need IOStream. Anyway, we'll just keep it. All right. So the next step is, okay, wait, it says creating a window. I haven't created a window yet. All right, let's see if we can get GLFW up and running. First, create a CPP file and then include this stuff. Okay, be sure to include glad before GLFW. Okay, yeah, I did that. Glad includes and the required OpenGL headers behind the scene like gl/glh. So be sure to include glad before files that require OpenGL like GLFW. Okay. Now we create the main function where we will instantiate the GLFW window. Right. So we do GLFW init. Okay, is it like small? What is this? Expected a semicolon. That's weird. Anyway, GLFW window hint GLFW context version major. Major is 3. GLFW window hint again. Nope. Context version minor, right? GLFW window hint. GLFW OpenGL profile is GLFW OpenGL core profile. Okay. GLFW OpenGL profile. GLFW OpenGL core profile. All right. I don't know why this is commented out. Here window hint GL true. In the main function, we first initialize GLFW with GLFW init, after which we can configure GLFW using GLFW window hint. The first argument of GLFW window hint tells us what option we want to configure, where we can select the option from a list of all the possible options and its corresponding option from a large enum of possible options prefixed with GLFW underscore. The second argument is an integer that sets the value of our option. A list of all the possible options and its corresponding values can be found here. Okay. If you try to run the application now and it gives a lot of undefined reference errors, it means you didn't successfully link the GLFW library. Okay, hopefully this won't give any such errors. Oh shit. Main must return a value, but I was returning a value. Okay, cool. We're not getting any errors. Nope. That means this is configured correctly. Since the focus of this book is on OpenGL 3.3, we'd like to tell GLFW that 3.3 is the OpenGL version we want to use. This way, GLFW can make the proper arrangements when creating the OpenGL context. This ensures that when a user does not have the proper OpenGL version, GLFW fails to run. We set the major and minor version both to 3. We also tell GLFW we want to explicitly use the core profile. Telling GLFW we want to use the core profile means we'll get access to a smaller subset of OpenGL features without backwards compatibility. We no longer need to know that on Mac OS X. We need to add this. Okay, so that's why this was in this was commented out, because you only need to add that in Mac OS. Make sure you have OpenGL 3.2 or higher. To find OpenGL version of your machine, use glxinfo on Linux. Anyway, so this runs. Next, we're required to create a window object. This object, window object, holds all the windowing data, and it's required by most of the GLFW other functions. Okay, cool. So we're going to create GLFW window pointer. GLFW, and then W is for window pointer, call it window, and can I call the function GLFW create window. Right, make it 800 by 600. Okay, so I think this is the title. And now for the last arguments. If window equals null, standard cout. Okay, so we do need IOStream here. Fail to create a GLFW window. That's fine. And then we call GLFW terminate. And then we return a non-zero value. Okay, so if it's not null, we'll call GLFW make context current. And then we pass the window pointer as the argument. Okay. The GLFW create window function requires the window width and height as its first two arguments. The third argument allows us to create a name of the window. For now we call it an OpenGL, but you're allowed to name it however you like. We can ignore the last two parameters. The function returns a GLFW window object that we'll later need for other GLFW operations. After that, we tell GLFW to make the context of our window the main context on the current thread. Alright, makes sense. In the previous chapter, we mentioned that glad manages function pointers for OpenGL, so we want to initialize glad before we call any OpenGL function. Okay, so this is how you initialize glad. Okay, we're supposed to do it after the window, right? If not glad load GL loader, glad load GL loader, and then pass it glad load proc. Okay, we have to pass it GLFW get proc address. And then we are casting it to glad load proc, I think. Okay, it's all small. All right, that works. And if it doesn't return it correctly, then we are just gonna exit again. All right, we pass glad the function to load the address of the OpenGL function pointers, which is OS specific. GLFW gives us GLFW get proc address that defines the correct function based on which OS we are compiling for. All right. Before we can start rendering, we have to do one last thing. We have to tell OpenGL the size of the rendering window, so OpenGL knows how we want to display the data and coordinates. With respect to the window, we want to set those dimensions via the GL viewport function. Wait, we already set the window size here, right? Then we have to set the rendering size. Okay, OpenGL size of the rendering window. All right, so GL viewport. Okay, it takes 4 arguments. By 600. Okay. Yep, same as this. The first two parameters of the GL viewport set the location of the lower left corner. Okay, lower left corner of the window. The third and fourth parameters set the width and height of the rendering window in pixels, which we set equal to GLFW's window size. Fine. We could actually set the viewport dimensions at the value smaller than GLFW's dimensions. Then all the OpenGL rendering would be displayed in a smaller window, and we could, for example, display another element outside the OpenGL viewport. Interesting. Behind the scene, OpenGL uses the data specified via GL viewport to transform 2D coordinates it processed to coordinates on your screen. For example, a processed point of location minus 0.5 0.5 would, as its final transform, be mapped to 200 450 in screen coordinates. Note that processed coordinates in OpenGL are between -1 and 1, so we effectively map from the range of -1 to 1 to 0 to 800 and 0 to 600. Okay. However, the moment a user resizes the window, the viewport should be adjusted as well. We can register a callback function on the window that gets called each time the window is resized. This resize callback function has the following prototype: frame buffer size callback, GLFW pointer window int width and height. The frame buffer size function takes a GLFW window as its first argument. Is this gonna open a window? No, it has errors. What is this? Unresolved symbol, glad GL reboot. GL view port. Word. Is this causing the error? Nope. Glad load GL loader. Glad. Yeah, this seems to be well supposed to be correct. It's working with autocomplete. Did I not write it correctly? No. Still saying unresolved externals. Okay, it runs till here. Okay, I saw a window opened. Yep, not giving any errors. Alright, I think this has some issue. Okay, this is all GLFW stuff. GLFW seems to be loaded correctly, but glad, I'm calling a glad function here and it's giving me an error. I've added glad.h here. Wait, let me check this again.
We'll now configure our Visual Studio project in order to access the web.
Could you explain what you are going to do? I hear you. Yeah, sorry, my I'm using this microphone, so that's why the audio is a bit bad. I'll try to speak up. I am just trying to learn OpenGL. I'm just following along on this learnopengl.com and also using Victor Gordon's videos as a reference. Just 1 second. All right, cool. So right now I am just stuck on glad error. GLFW seems to be working fine. So I'm just gonna follow with this tutorial and see if I missed anything.
Your libraries folder. Click OK, and now do the same for your library directory with your lib folder. Here we will write GLFW called OpenGL. It's just the name. Last thing you have to do is to drag the lat.zip file from your project folder into your source files folder. Then right-click source files and add the item called C++ file, name is main.cpp, and click on add. Now, in order to test that the
Okay, I think I've followed all the steps. I've added this glad.h here. Also, I have added glfw 3.lib and OpenGL.lib under the linker, and also I have added both the directories, the lib path and the include path, right here. And glad is also here, glad.h. So this should be fine. Okay, this is a glad.c file. I think I copied over the wrong file. This is not supposed to be glad.h. Okay, let me just remove that. Okay, did I download glad.c? Yep. Okay, let's add that. Hopefully that should get rid of the error. Yep. Okay, we can continue. Okay, I already did this. Okay, yeah. The frame buffer size function takes a GLFW window as its first argument and two integers indicating the new window dimensions. Whenever the window changes in size, GLFW calls this function and fills in the proper arguments for you to process. Okay, so this function gets called every time the user resizes the window, and it tells you what the size of the window is, so we can just pass those arguments into GL viewport again, so that the size of the window has changed. We're going to change the viewport of OpenGL as well. We do have to tell GLFW we want to call this function on every window resize by registering it. So this callback we can register by saying GLFW set frame buffer size callback. When the window is first displayed, frame buffer size callback gets called as well with the resulting window dimensions for retina displays. Okay, we don't care about retina displays. There are many callback functions we can set to register our own functions, for example. Okay, so I'm just gonna call this and see window frame buffer size callback here, and then it'll call this function. Wait, is it supposed to be outside main? Right. And then finally, when the window is first displayed, yeah, we did that. We don't want the application to draw a single image and then immediately quit and close the window. We want the application to keep drawing images and handling user input until the program has been explicitly told to stop. For this reason, we have to create a while loop, and that we can call the render loop. That keeps on running until we tell GLFW to stop. The following code shows a very simple render loop. Okay, so we're going to add the render loop. While GLFW window should close, and then we pass it the window, it's going to keep running. All right, so I just add it here. What does the chat say? I know Java, JavaScript, PHP, Python, some C2, but I don't know if I will be able to help you with a lot, to be honest. Yeah, that's fine. We'll figure it out. Which error is saying the term? Oh, okay, are you talking about the previous error? We already fixed that, so that's cool. GLFW window should close. And then we give it the window pointer as the argument. So when this, while this is false, these two functions are going to be continuously called. GLFW swap buffers and GLFW poll events. Okay, so now hopefully the window is not going to close instantly. Yep, there's our OpenGL window. And okay, yeah, as we resize, I think this is also working. Wait, maybe we can just put a print statement here and see if it gets called every time the window resizes. Cout resize. Okay, yep, our callback is also working, so that's cool. One last thing, as soon as we exit the render loop, we would like to properly clean slash delete all the GLFW resources that were allocated. We can do this via the GLFW terminate function that we call at the end of the main loop. GLFW terminate. This will clean up all the resources and properly exit the application. Now try to compile your application, and if everything went well, you should see the following output. Yep, that's exactly what we see. Our OpenGL window. Okay, if it's a very dull and boring black image, you did things right. If you didn't get the right image or you're confused as to how everything fits together, check the full source code here. Okay, we didn't get any issues, that's good. Okay, now the interesting part. We also want to have some form of input control in GLFW and can achieve this with several of GLFW's input functions. We'll be using GLFW's GLFW get key function. Okay, that takes the window as input together with a key. The function returns whether this key is currently being pressed. We're creating a process input function to keep all input code organized. Cool. Okay, so we're going to create a process input function that takes in GLFW window as an argument. And okay, it calls the GLFW get key function. And we're checking if the key is escape, then we set the GLFW set window should close to true. All right, so we need to pass in the window and GLFW key escape. Equal GLFW press press. Then we call GLFW set window should close. And again we pass the window and true. Okay, so hopefully when I press the escape key it should exit. And it does not. Okay, yeah, I forgot to call this. We need to call process input inside of our render loop. Yep. I'll just put in a comment saying that this is our render loop. Okay, I set it as a Pascal case. Okay, yep, that works. So now on every iteration it's going to check if the escape key is pressed, and when it's pressed it sets the set window should close to true, and then on the next iteration of our render loop this condition will be false, which will exit out of this loop and we will terminate our program. This gives us an easy way to check for specific key presses and react accordingly every frame. An iteration of the render loop is more commonly called frame. Okay, now we're going to move on to rendering. We want to place all the rendering commands in the render loop. Since we want to execute all the rendering commands each iteration or frame of the loop, this would look a bit like this. So this is our render loop. We are taking the input right here, and then we do all of our rendering commands, and then this is the check and call events and swap the buffers. Okay, that's the last thing we need to do, and our rendering will go down here. Just to test if things actually work, we want to clear the screen with a color of our choice. At the start of frame we want to clear the screen, otherwise we would still see the results from the previous frame. This could be the effect you're looking for, but usually you don't. We can clear the screen's color buffer using GL clear, where we pass in buffer bits to specify which buffer we would like to clear. The possible bits we can set are GL color buffer bit, GL depth buffer bit, and GL stencil buffer bit. Right now we only care about the color values, so we only clear the color buffer. Okay. Okay, so this is all the rendering stuff we need to do. We can clear the buffer with a particular color here using GL clear color, and this I think is RGBA values, and then we say GL clear, and then we tell it to clear the color buffer bit. If we don't do that, it shows the color of the previous frame. Yes, that makes sense. Okay, yeah, now we have changed the color of the window. The full source code of the application can be found here. So we are done with 2 chapters. Still a long way to go. It's actually time for lunch, so I think I'll be streaming a little bit after lunch. I want to complete this part at least. Alright, see you guys later.